guys, welcome to Learn Tech from Zero. Today we'll be covering further Zero to CCNA Packet Tracer Lab. So that way you can master CCNA quickly and understand all the exam objectives. So we have already covered up to step 4. So if you're new to this video, I would suggest you start with step 1, where we explain you the overview of the network design and how we'll be designing the network in general. So let's start with step 5. So in step 5, we are saying that we'll be connecting switch 1 to switch 2. So based on the design, you can see that switch 1 is in the head office, switch 2 is in the head office, and switch 3 is in the head office. So we are not talking about the branch switches. We will work on the branch later on. You can see that these two sites are connected using a serial connection so that these two sites can communicate with each other, and this is the head office, which will also maintain all the configuration for branch office, etc. So this is for higher level, like when we cover advanced topics on CCNA, so don't worry about this too much for now. So right now what we will be doing is we'll be connecting switch 1 to switch 2. So right now we are just connecting devices, so we are still in the early stage of creating a network. So let's just do the connection. So we'll be connecting switch 1, switch 2, switch 3 together. So in this design right now, switch 1 is still a layer 2 switch, so it becomes a layer 3 switch when it can communicate between different VLAN, virtual local area network, and then it can forward traffic based on the routing table. So when switch can create routing tables, follow routing protocols, for example OSPF, etc., and then it can do ACLs like access control list, where you block or allow network traffic based on IP addresses, port numbers, or protocols, etc. It becomes a layer 3 switch. So layer 2 right now it's still a layer 2 switch, because in the future what we will do is we will make a separate VLAN where these 3 devices are in one VLAN and these devices in separate VLAN, and then what will happen is these are the access switches. So access switches are for accessing internet. So all these devices will be connected to the access switches, and these access switches are on different VLANs. And then right now the design is they will forward the traffic to distribution. So this is the access switches. It will forward the traffic to distribution switch. And because it's not a layer 3 switch yet, where it can't do IP internet IP routing, to create VLANs you need IP addresses. So if it's not a layer 3 switch, it won't understand IP routing. So what we'll do is, in this current design, this layer 2 switch, which is known as a distribution switch, will forward all the traffic from different VLANs to the router. So router, in the initial stage we will configure router for communication between different VLAN using the method called router on a stick, ROAS. And then what happens is all the traffic goes through the router and then the router checks where the traffic should go. So it checks the IP addresses and the VLANs and everything, and it will forward the traffic. So the initial design is, let's say this is VLAN 10, these 3 devices and VLAN 10. We will configure later on, so I'm giving a quick overview. So this is VLAN 10. So they're accessing the internet through this switch, which is access switch. And then what access switch does is they can only create VLANs and then obviously forward data based on MAC addresses, etc. So don't worry about this too much for now. So what happens is when they communicate, this switch, access switch, will forward the uplink the information, the data traffic, to the distribution. Because this is still a layer 2 switch, in that case it's just distributing, and it's not making SPIs like on switch layer 3 switches. You need to have switch virtual interface for VLANs to communicate with each other. So if this PC wants to communicate with this one, and this one is still a layer 2 switch and we haven't configured SVI, what it will happen is it can't make the decision, so it will forward it to the router. Then the router will check, okay, it needs to go to, let's say this is VLAN 20, so this computer wants to communicate with this computer, so it needs to go to this area. So the router will check his routing table, and it will check the information on router on a stick, and then it will forward the data to this side using one of the ports on the router. But later on, what we'll do is we'll remove router for inter VLAN communication, and we will make switch 1, the distribution switch, as a layer 3 switch, and this switch will make the decisions, not the router. So the information goes from here to here to the distribution, and it will check the routing table and everything, and then it will make the decisions, and then it will send the information. So router on a stick is ideal for inter VLAN communication for smaller networks or medium-sized networks, but high level traffic, big enterprises, or be very extremely busy environment, we should not be using router as for inter VLAN routing. We should be using a layer 3 switch for inter VLAN routing for efficiency, and also for like a basically efficiency and like really fast. So this layer 3 will be way faster than using a router for inter VLAN routing. Okay, so right now what we are doing is we'll be connecting those devices. So this is a distribution. What we'll do is we'll just rename it so that so it's a distribution. So dist should tell you that it's a distribution, and let's say this one would say access for accessing internet. All right, so what we'll do is we will use a cable to connect. So if you go to the guidance, it says that what we need to do is you can read all these this is for future. So what we are doing is we will be covering all these technologies in the future, so don't worry about this now. So we will be using a cable called straight through cable. So straight through cable means basically, I've explained it in the previous video, step 4, so I will do it again. Straight through cable means when you connect different devices. So let's say when you are connecting PC to switch, switch to router, etc., and when you are connecting switch to switch, PC to PC, we should be using as per CCNA, it's a crossover cable for connecting same devices. But even though we are using the same device, we should be using a crossover cable, but this is eliminated due to a technology called auto MDIX, so we will not be using this. So right now you can use any cable, straight or crossover, it doesn't matter. Crossover is a legacy, so right now it's all straight through cables. And then what happens is it detects automatically using auto MDIX, so you don't have to worry about this too much for now. So I'm just going to go to the connections right here, and then I will choose a straight through cable. So I'm just going to see. Okay, so you can see that this is console cable, straight through cable, crossover cable. So crossover is connecting different similar devices, but right now we are using a copper straight through cable. That's the standard at this point. So what I will do is I'll just do that. So what are the ports that we need to connect to? So we'll be connecting gigabit Ethernet port number 2 to switch. All right, so we'll be connecting gigabit Ethernet 2 from switch 1. That's the port number on switch 1, and on switch 2 gigabit Ethernet port number 1. So the reason we are using the port number 2, because the first port, gigabit port number 1, is used for the connection between the router and the switch. Okay, so we have so we will be using the second one. So I'm just going to click on these. I'll be choosing gigabit Ethernet 2, number 2. And then on the switch 2, I will be using the first one, because on packet tracer they are only limited to 2 gigabit Ethernet ports, but on modern devices you will find more. So when we say gigabit Ethernet or fast Ethernet, what it means is gigabit Ethernet can support up to 1000 megabits per second, so 1 gigabits per second, and fast Ethernet can support up to 100 megabits per second. So what happens is you can connect different port. So you can connect a fast Ethernet to gigabit, gigabit to fast. So whichever is the slowest will become the speed. So let's say if we're connecting gigabit to gigabit, what happens is the maximum speed is 1000. So in that case, both the port can send data on 1000 megabits per second. But if we connect gigabit to fast Ethernet, what will happen is, because the fast Ethernet is slower than gigabit, so the fast, what happens will be the 100 megabits per second will be the speed for the connection between two devices. So whichever has the lowest speed, it becomes the standard speed for that connection. So it is ideal to make sure that we always connect two ports which has the same speed. But you can also connect two different ports, but the slower one will become the main speed. All right, so I'm just going to be using this gigabit 1. So I have done it. So I have followed the instruction. I have connected switch 1, which is the distribution switch, which will later on in the future will become the main core switch, and then switch 2, which is an access switch for access, so that end devices can connect to on this port. So that's it. So we have done the connection. What we can do is we can simply go and do step 6, which is connecting the other access port. So in the next video we will start with step 7. So in the step 6, it's the same thing. What we will do is we will be connecting as switch 1 to switch 3. So this is the distribution switch, and then we will be connecting the access switch to this distribution switch. So the reason, you can see that this is all in one place, so it's like one local area network. But what this actually mean is, it's one big place, right? And then this switch is in one building, and this is in another building, and they are connected using the cables. So I'm just gonna try to do this, but right now the problem is, let's say I want to use the connection gigabit port, but you can see that I have used all the gigabit ports. So right now you can see that they are on packet tracer is only limited to 2 gigabit ports. So I have used one to connect to the router, and the other one is to connect to the switch 2. So I don't have any more gigabit ports, so I have to use a fast Ethernet port. And so in that case, I will be connecting the one of the fast Ethernet port to the switch 3's one of the gigabit port. What will happen is the speed will become the fast Ethernet port speed, which is 100 megabits per second. This is okay for CCNA, but in a real life ideal world, we should be using gigabit to gigabit, fast Ethernet to fast Ethernet. Okay, so what the instruction says, it says that switch 1 gigabit Ethernet 3, but we don't have 3. So I've mentioned, if no more gigabit ports, then you can use section C, updated section 6 below. So we'll ignore this and we will just use this bit. So updated 6 is if we don't have any more gigabit ports. So what we'll do is we will use fast Ethernet to number 23, port number 23, to fast Ethernet port number 1. So we are keeping this the same so that there is no mismatch error or any other errors. So just to make sure that we have a safer and clear environment, so we'll be using the same port. So this one will be fast Ethernet 23 to fast Ethernet 1, fast Ethernet 23 to fast Ethernet 1. Now what happens is, this is a gigabit port, the speed will be 1 gigabits per second, and this is a fast Ethernet port, the speed will be 100 megabits per second. So this one is 1000 megabits, this is 100 megabits, but it's okay in the lab or any or for testing and covering CCNA exam objective. This is okay, but in real life ideal world, we should be making sure the distribution to core, core to distribution, those uplinks from the access should always be gigabit ports. Okay, what's the next one? That's it. So what we have done is we have connected the devices. So on the next video, what we will do is we will connect R2 to switch 1. So you can see that R2, and then we will be connecting it to switch 1 in that branch. So I think this one will be switch 1. So let's not go any further. We will cover everything step by step. If you have any questions, just leave a comment, and you can find everything for free on our website, which is Learn Tech from Zero. So thank you so much for your time, and I will see you next time.